which is protocol : / hostname : port / path. Right? Like, so if you've ever gone to google.com / search / whatever, right? That's / path, right? That's basically how you remotely talk to something on the internet that isn't just using your web browser. When you're writing code, there's also, like I said, there's more than just REST APIs. There's all sorts of different remote services you can communicate with. For example, in databases, when you remotely communicate with a database, it actually has its own protocol. When you run an SQL query, actually what you're doing underneath the hood is you're actually speaking a non-HTTP binary protocol. Every database usually has its own protocol. So again, a protocol is how two things on the internet communicate with each other. On a client, usually on a client and a server. That server may not speak HTTP, and 99% of the time it probably doesn't, because HTTP is actually very inefficient. I won't get into why, but just understand that not everything is just a web browser. There's a lot of other stuff out there, and this is just like a very small subset of concepts that you need to understand. If you want to get into databases and data engineering, if you're using like Apache Spark, same thing. When you're dealing with Spark, it has its own protocol for how it communicates things over a network. The same is true of email servers as well. So again, same thing, whenever you send an email, it's not using HTTP actually. It's actually using SMTP and another one called IMAP. When you want to receive email, you use something, there's two, when you receive email, you can either receive email via POP or via IMAP. And IMAP is the general standard, and now there's another standard out, there's another standard built by the Fastmail people called JMAP. So this is, all these things that we use day to day all have their own custom protocols. These are generally just defined by standard files. So W3C is for, so another standard device is W3C. It's just for HTML. So HTML and JavaScript. So these are all standard files, right? So if you're wondering like, how do like Microsoft, Google, and Firefox agree on what HTML is? They're all part of the same standard body. And each vendor just agrees to implement the spec. So your web browser is actually just speaking a spec. Whether it's dealing with HTTP, file downloads, whatever, all those are using standard protocols over a network. But everything's essentially built with the same technology. So again, so now to visualize it. So this is the only thing you need to understand is you send packets. Packets communicate over a network. And you have a client. You have a client with different servers. Different servers can speak different protocols. And the client, one thing that people miss is that the client needs to speak the same protocol. So this is why we write. This is actually why we write SDKs. When you write an SDK, generally it's just a specialized client that knows how to speak whatever language the server is. Right? Like so, both have to agree on a protocol. So when you have a client server, they both have to speak the same protocol. And again, and then in order to access the remote computer, whatever it is, you have to know whatever the host name is and the port it connects on. And then that port, basically that host name and port speaks a particular protocol. So the client and server kind of have to handshake and agree. Do you speak English? Yes, I speak English. Good. That's literally what happens. There's this handshake that happens, and then basically that's how you get two things communicating over a network. If you've ever dealt with WebSockets are also, turns out, a protocol. So that real-time streaming thing, it's just a really efficient way to stream data incrementally over a network. So WebSockets and streaming are also just another protocol with HTTP actually. It's built on top of HTTP. All right. So before we get into Docker and all that other fun stuff, I just want to do a quick check-in. Have people set things up yet? For the most part? Are you able to, how are y'all doing back there? Docker Toolbox? Getting it? Okay. Okay. Anyone not have Docker installed yet? Paul, you do, right? Yeah. Okay. Okay. So if y'all have Docker installed, okay, now we get to the, okay, one more time. Speak up and forever hold your peace. Good? Come on, don't be shy. One of you is silently failing. How are you doing? You got it? Docker, you can do Docker run whatever? Okay, yeah. Did any of you verify that it actually works? Okay, to verify, let me see. So, to verify it actually works, do me a favor and type, let's see, Nginx. I just want to do something simple. I want to see that, type this. Docker pull Nginx. Type this and make sure it works. Open up whatever command line you're doing and just make sure Docker pull works. Very bare bones basics. Just want to make sure you can download stuff. Okay. All right. Simple enough? Docker pull. Does anyone see anything breaking? As long as it's downloading something, you're good. That's all I need to see. I don't need to see it running or anything. Okay. All right. So let's get into some of these things now. So again, for those of you taking pictures, again, I posted the GitHub link on the meetup, so you can just get this for yourself directly. I'm still scrolling through the exact same notebook. It's everything relevant is going to be posted right on the meetup page. This is already all open source on the internet. You can just go directly grab it. Okay, so Docker container and terms. So virtual machines. Let's start there. Has any of you ever used a virtual machine before? Okay, good. Okay, so yeah, virtual machines, right? Like what do they essentially do? Virtual machines in the form of, I'll just say in the form of VirtualBox, Hyper-V, VMware. Those virtual machines, not like a Java virtual machine. That's another thing. Just there are different kinds of virtual machines. The main one I'm going to talk about in the simplest terms is you have something called a hypervisor, and the hypervisor is capable of running one or more virtual machines. What a hypervisor does is it loads from an image file, like a .vdi or whatever your big virtual machine thing is. It's a binary format for storing the state of a computer. And what a hypervisor does is it runs one or more virtual machines, very similar to what Docker does with Docker containers. Right? Like so, turns out Linux, actually Windows and Mac, are actually just hypervisor. It's actually hypervisors and virtual machines underneath the covers. So if you're running not Linux, it's actually not containers. It just emulates containers. So underneath the covers, if you're wondering like why does this work on Linux and not Windows, it's because it's actually very different implementations of things.
You're talking about monolithic kernels and microkernels.
Sorry?
So are you talking about monolithic kernels and microkernels?
Just in general, you have a hypervisor,
yeah.
right? Hyper-V, whatever, right? Yeah, and then that runs one or more virtual machines.
Oh, okay. So I thought you were talking about the normal operating system that we have on our machine.
No, just remember, so you're probably one of the only people here with the background actually to tell the difference between what I'm talking about. So I'm trying to super simplify it.
Yeah.
All right, like so in general, that hypervisor could be Hyper-V, or it could even be like a VirtualBox daemon. Right? Like so there are different ways of running virtual machines, right? And basically it just emulates, Docker just emulates running what is a proper container runtime on Linux. So when you're running Linux, you're actually running real containers. So what's the difference between a container and a VM? A VM just basically that hypervisor loads the image from disk, and then what it does is it emulates hardware in software. It actually emulates so basically all the bits we're sending to the computer and everything else, it actually just emulates all that in software. Right? Like so one of the first companies to do that was VMware, like all the way back then. Right? Like so, in that case, they actually emulated Windows, right? Like so, they dug into the kernel API, the Windows 32 kernel, and they understood like what a system call was, and then basically when that system call calls out to the hardware, the virtual machine responds instead. So it doesn't know whether it's a virtual machine or whether it's a real bare metal or not. So if you've ever heard of bare metal or VMs, now you know the difference. So for example, AWS, I believe still uses Zen.
Yes.
Yeah. So Zen's another like large scale hypervisor. So when you spin up a machine, it's just a bunch of servers, and then it just uses Zen. Zen is another hypervisor. That's actually what AWS is actually made of, if you were curious. There's a lot of other stuff, but the core of it is spin machine up. That's Zen. That's actually a hypervisor responding to you. So that's the cloud. It's actually basically a hypervisor.
And that goes with Azure as well.
Yep.
A lot of things on Azure runs on Hyper-V. Yeah.
Oh, really? Okay.
So at the underlying layer, they've got a mix up of things at their bare metal stuff. Some of the VMs, if you spawn up, they would go on a hypervisor.
Right.
On a hypervisor.
Yeah, but there's different ways of spinning it up too.
Right.
Yeah.
And some of them would be offloaded to, let's say, a Zen-based.
Right. So why am I talking about all this? Because virtual machines are slower. It actually really affects your math code. So if you're running TensorFlow or you're running your whatever, actually you're even getting fixed CPU cores back. Virtual CPU. If you've ever seen vCPUs on Amazon, those are fake. Right? So you're not getting like real hardware cores actually. That really affects the math. That actually really affects the math that you're running on. So know all I'm going to say is know the difference between bare metal and VM. Like, so you have emulation and you have bare metal. Bare metal is cheaper, faster, but not as robust in terms of like distributed systems and everything else. Like it's harder. Essentially, it's harder to maintain. That's why everybody uses cloud nowadays, even if it's not as efficient. Not everybody needs super efficiency though. There's only very specialized applications where you need that. Some of those things will run on bare metal. So if you think about like big on-prem installations of things, like when you hear about like HPC, right? All that's actually using very different hardware and connectors and everything. So if you're curious, for example, Google something called Mellanox. Mellanox, M-E-L-L-A-N-O-X. It's actually special wiring between different CPUs or between different chips. So it's a way of sending data faster. The reason I mention that is because, coming in, good to go. Yeah, so there's things like that where that actually affects that again. That all affects the performance of your whatever deep learning training you're doing. The hardware you have actually affects a lot of the performance. Right, like so again, systems architects are typically the people that deal with this. As beginners, just understand that you have virtual and you have bare metal. Right, and then in bare metal land, there's all sorts of different ways you can set up a box. Like so, if you've ever built your own box, your own desktop, there's all these things you have to like configure. Like you have to get the CPU, the RAM, and everything else. There's also like special interconnects you can get and everything else. So this generally only comes up in the data center land, in data center land. But if you've ever seen like they have InfiniBand, for example, another one's InfiniBand. In Azure, I think only Azure has InfiniBand. Yeah, Azure I know has InfiniBand, for example. It's a special interconnect for the CPU and the GPU. So it's actually it allows for faster training of things. If you run a large physics simulation, generally that's generally all using HPC tech, and generally it's very expensive InfiniBand. That's actually what large scale supercomputer clusters are run on.
That's because they're using vector computers.
Yep.